So when we talk about the basicity of amines, one of the things we want to remember is that amine always has a nitrogen with a lone pair, and that lone pair of electrons will always accept a proton from any acid. So this statement here, aqueous solutions of amines are weakly basic because of the formation of hydroxide and quaternary ammonium ions in water. So it's a seemingly simple statement, but it actually expresses a relatively complex set of processes. So let's take a look at those. So this slide has three different examples of primary, secondary, and tertiary amines respectively dissolving in water. Let's take a look at the very top one where we have a primary amine here, ethylamine, dissolving in water. So this phase here, aqueous, means that each molecule or ion is completely surrounded by water. Now, like weak acids, weak bases, when they're dissolved, not only is each molecule completely surrounded by water, but each molecule actually reacts with water. So down here at the bottom of our slide, it is helpful to think of water as being composed as a proton and a hydroxide, because that's how weak acids and weak bases see water. Okay, so looking back up at our equation, our primary amine, 2 hydrogens, 1 alkyl group. This reacts with water, and as a base, it's going to pluck a proton from that water molecule, which leaves a hydroxide anion and then the quaternary ammonium cation. So the primary amine has 2 hydrogen bound directly to the nitrogen, and then after it reacts with an acid, in this case water, it has 3 hydrogen directly bonded to that nitrogen and an overall positive charge. Now, we are going to have to pay attention to charge as we look at acid-base reactions, and on the left-hand side of the equation, our overall charge is 0, and on the right-hand side, our overall charge is 0 as well. Now, the charges don't have to be 0 on each side of the arrow, but they do have to be the same on each side of the arrow. Alright, so now let's take a look at a secondary amine reacting, dissolving in water, and our example is diethylamine, and the nitrogen is bound to 2 alkyl groups and 1 hydrogen. It acts as a base and plucks a hydrogen, a proton, from a water molecule to form hydroxide, that's what's left of the water molecule, as well as a quaternary ammonium cation. So on the left-hand side, our secondary amine has 1 hydrogen directly bound to that nitrogen, and on the product side, there are 2 hydrogens as well as an overall charge of positive 1. And last but not least, we have our tertiary amine. Triethylamine is our example, reacting, dissolving in water. So like the other amines, it's going to pluck a proton from the water molecule, and the water molecule then becomes a hydroxide once it's lost that proton, and our tertiary amine gains a hydrogen directly bonded to that nitrogen as well as an overall positive charge. Now, all of these amines are weak bases, and if you remember from when we discussed weak acids in previous chapters, the equilibrium is always going to be favored on the side of the weaker acid and base. So each one of these equations, we notice there's a double arrow, which means there's an equilibrium, and so the equilibrium is always going to be favored on the left-hand side, which means the concentration of hydroxide is always going to be much smaller than the concentration of the amine. However, there is a formation of that hydroxide, which means that the pH is going to increase and that solutions of amines are basic.